All right, thank you very much, Solius. I appreciate the chance to present. Thanks to the folks at Know Magic, particularly Solius, for setting this up. The topic, as it says here on the splash screen, is that we're going to talk about connecting SysML with PLM, ALM, CAD, simulation, requirements, and project management tools. And I think that's an ambitious project, and it should take us up till lunchtime, probably lunchtime tomorrow. But we're going to try to get it all done in about 1 hour. I am going to ask you to hold questions till the end, simply so that I can present the material in the form in which it's packaged right now. And then I'll be happy to take either written questions or, if there is time, questions here today. Just as a brief introduction about Intercax, we are a spin-off out of the Georgia Institute of Technology starting back around 2008, and our offices are still located in Tech Square in Atlanta. We also have an office with some software developers in Pune, India. Our primary focus since we got started has been software for model-based systems engineering. And our products include Syndeia, which is the product we will be talking about today, our PLM, CAD, etc. integration platform, and a number of tools that are involved on the SysML parametrics side, executing SysML parametric models, including Paramagic, which stands for Parametrics for MagicDraw, a MagicDraw plugin. We have been working with MagicDraw since about 2008, really since we got started as a key partner. In addition to software, we do a lot of training and consulting, typically in collaboration with Georgia Tech, and we've trained over 3,500 students since we got started in that business in 2008. We have customers in government agencies and in a wide variety of commercial organizations. My agenda is fairly ambitious, as I said. I want to talk a little bit in an introductory fashion about model-based systems engineering, model-based engineering, and what role Syndeia has to play in that. And then I want to dive fairly quickly into actually talking about specific use cases and demonstrating the Syndeia software for some specific tasks. We'll talk about a number of different areas, and then I want to just end with a short discussion about where Syndeia and really I think the whole MBE field is going and what the future of that looks like. So we'll get started then by talking about what model-based systems engineering means, because that's really the reason we got into this particular business. The idea behind model-based systems engineering was to create a single unified model of the system. The idea being is that if you could capture everything about the system in a single model, you could generate all of the documents, all of the artifacts, all of the systems engineering views that you needed from that single source of truth, essentially projecting them into the correct space. And if you needed to revise your model, you could generate a new set of updated documents with a few clicks of a mouse. That was the ideal, that was the vision of model-based systems engineering. But then here's the reality. The reality is that the engineering software toolset at almost any major vendor is diverse. It comes from many different software vendors, and these customers are storing their system data all over the place, bits and pieces in PLM systems, ALM, CAD, spreadsheets, databases, and SysML models. And that gives rise to the usual silo problem that we have in engineering processes, where even the systems engineering task, say with SysML modeling, can become a silo in its own right. But that's the world we have to live with, because customers want to work with best-in-class tools. They have to work with legacy tools. They have to work with their customers and their suppliers' tools. So this is the reality as it exists. What we need to do is take this concept from MBSE and extend it into the complete engineering process. And that's what we're calling MBE, model-based engineering. Model-based engineering doesn't mean to us that you use models to do engineering, because we've been doing that all along. It means this idea of creating a single unified model extending over all the tools and all the data repositories. That is MBE to us. And that means that you end up creating some kind of a model that looks something like this, where you have elements in each of the different tools that are linked to elements in other tools. Now, in the modeling world, this kind of model is called a graph. And in this world, the nodes of the graph are things like structural elements, their behaviors, their requirements. They're not files now. They're elements within models in each of those tools. And the edges of the graph are compositional relationships, constraints, dependencies, flows, a wide variety of different kinds of relationships. So that's what we somehow need to capture. So why do we want to do this? To us, MBE means that we can create a unified system model with a network of persistent connections, and that persistence is an important feature. Connections between model elements in different tools and repositories. Because if we can do that, then there's a lot of things that engineers can now do that they couldn't do before. They can begin to search and access system data in all the different remote tools where it lives. They can begin to take system data in one tool and transform it into a model in a different tool that mirrors that data. And then they can compare and they can synchronize the data across those connections as the models evolve. And also, you want to be able to trace and visualize and query those connections. Ask, what am I connected to? What am I going to impact if I make a change here? So that is the goal. We need a way to create and maintain and visualize the information in this graph model. And that finally is where our product Syndeia comes into play. Now it's worth noting that we're not the only player in this at all. In fact, this is a general movement, I think, in the engineering community, this idea of being able to connect different tools. Many of the different software vendors have different pieces of this that they are taking on. And I think in many respects those are going to be complementary pieces. But I'm going to try to talk specifically here about some of the use cases without getting too much into the mechanics of how we do that. I am going to use Syndeia to illustrate these points, but Syndeia is not the only approach to actually carrying out and supporting some of these use cases. Because I really want to focus today on use cases. It's easy to talk about connecting this tool and that tool, but if you don't do that in the context of what you want that connection to actually accomplish, then you're really just blowing smoke. You really need to be able to talk about the specific use cases and make those work in real production situations for this ideal to become anything more than an empty vision. So some of the things you want to be able to do is that you need to be able to see the information in these external tools. And this is actually the Syndeia dashboard. On the right side here, we're looking into, for example, a Team Center repository. And if in this Team Center repository there's information we need to be able to search for it. So Syndeia opens a search window and says, okay, show me everything with a GPS type of tag to it, to its name. And once you can find the information you're looking for, you want to create a connection to it. Let's say I want to create a link, what we call a reference connection, between an element in the SysML model called Aircraft Platform and an element in the Team Center repository called Aircraft Platform. If you can start to create these linkages and maintain them and manage them, then there's an enormous range of things that you can do. One thing is you can access that information. I can click on an element in the SysML model, either in the Syndeia dashboard or in the model itself, in a diagram, for example. And I can open, in this case, a CAD file showing me the contents of that model. That's what we mean by access. I can go right to that piece of information in the appropriate tool, at least if I have access to that tool. Beyond that, I can start to do what we call transform. I can take a model in one tool and transform it into an equivalent model in another tool. So at the top here, we have an IBD of a system showing the connectivity between the different elements of the system. And we have taken, using Syndeia, this block structure and created an equivalent block structure in Simulink. Now, this is not a one-time import-export kind of a deal. We need these structures to maintain connections over time, because the real problem in this kind of a situation is that everything is changing. The SysML model is changing, the external models are changing, the connections between them are changing. This ideal of a single system model, a total system model, is really just a snapshot in time. A lot of these models are in configuration managed repositories, others are time-stamped, and so we need to include that in the process, and we need to be able to recognize when things have changed, and particularly when models that initially matched in different tools no longer match. They no longer work together. So I need to be able to take this kind of model transformation that I've done and use it to compare these models going forward. This is another aspect of the Syndeia dashboard. It's its difference table. It says, okay, our SysML model, and in this case a PLM model, have changed. And we're going to highlight the changes that have developed over time on either model or both models as we go forward. And beyond that, under the right circumstances, we can even synchronize those models, potentially in either direction. We could sync a SysML model to a target model, like a PLM system, or sync the PLM system back to the SysML model so that we can update the models to bring them back into harmony with each other. So these are some of the broad use cases that we want to be able to do: search, connect, access, transform, compare, and sync. But in each set of tools, that means a different set of capabilities, a different set of tasks. So what we are dealing with here is a situation where in the past we've had these different silos of engineering, and the communication between them was by people exchanging documents, people writing things on whiteboards and in PowerPoints. And we're going to try to change that to an architecture that looks something like this. We're going to use a SysML model as a central hub, a high-level roadmap for the system, a clearinghouse for the system. But we're going to link it to models in all of these external tools so that they can remain at some level consistent with each other. And that's where Syndeia comes into play. Now, just to briefly give you the history of Syndeia, the first generation of Syndeia was released about 2 years ago. It was called SLIM at that time, which stood for System Lifecycle Management. Unfortunately, the people doing software lifecycle management thought that that was infringing on their territory. So we renamed it as Syndeia, a Greek word meaning the practice of bringing things together. So in that SLIM Syndeia 1.0 release, we were really looking at integration to 4 specific tools, as from either MagicDraw or from IBM Rational Rhapsody. On the PLM side, that included Siemens Teamcenter and PTC Windchill. It also included MySQL databases and Excel spreadsheets. A year later, that is a year ago, we introduced Syndeia 2.0, and we increased the number of tools that we connected to. Specifically, we started working with mechanical CAD, again Siemens NX and PTC Creo, and Simulink from the MathWorks. So we increased the number of different kinds of tools and the number of different use cases that we were trying to support. We also upgraded the search and access capabilities over the first generation. That is our current commercial release, but the next release is due out at the end of this month, Syndeia 3.0, and that's increasing the number of interfaces as well. That's going to include DOORS NG, it's going to include JIRA, and it's going to include Git interfaces. So we're increasing not only the number of tools we're interfaced to, but the different kinds of tasks that people are using them for. And just to give you a little heads up, this is not the end. We're looking at some additional tools that are going to be part of Syndeia going forward, and we'll talk a little bit about those at the end of the talk. And this is just a review of some of those capabilities. I will also say that visualization is a key factor for us. But just to end this part of the presentation, I do want to say that while this is a grand vision of everything connected together, that's not the way the real world works. Our focus is on helping customers implement specific use cases, specific connections to do important, high-impact tasks. And Syndeia can be purchased in a modular fashion. You can purchase just those interfaces that you need to do what you need to do. And we work with those customers to make sure that the use case they have is being supported. Now, we use standards. Syndeia is a standard platform, and we use standards like SysML and REST and OSLC where they support the customers, where it makes sense to use them to meet certain use cases. So standards are important to us, but our highest priority is to actually support what the customer needs to do in a particular task. So let me dive in quickly to the actual demonstration part of what we're talking about. And typically we like to do this from a particular scenario, and we're going to take one that's actually been used in the systems engineering community a lot recently. We're going to talk about developing a system model for a configurable UAV, unmanned aerial vehicle. And the system engineer who's tasked with doing this has to use a lot of different sources to build this model. They're working with a lot of different tools, including modeling tools, simulation tools, databases, and they're dealing with a global supply chain, many different suppliers and subcontractors who of course have their own tool sets. And from the system engineer's point of view, that person wants to do more systems engineering, more modeling, more simulation, and they want to spend less time on the administrative tasks that system engineering has always been loaded down with. That's reconciling models, that's communicating models, that's worst of all, document exchange. Because the system as it currently exists for that system engineer looks something like this. At the top you have the various tools that the prime is involved in, PLM systems, CAD systems, Simulink systems, but you're also dealing with subcontractors who have maybe a different PLM system. You're dealing with databases of supplier material, maybe in a MySQL database. And today, all of the system architecture is captured in PowerPoints, in Excel spreadsheets. And any communication with these different tools, these different centers and their engineers and analysts is through those same kinds of documents. And we want to move from that to an environment where we can work with much less document exchange, where we can tie those tools directly into a system architecture model in SysML, but still talks as needed to all of these different separate tools. So with that, let me see if I can go and actually start to work from MagicDraw. I'm going to start out by creating a very simple structure for the architecture of a configurable UAV. It's got an aircraft platform. That's actually a system we're going to buy from our subcontractor. It's got software. It's got different payload components, because it is configurable. It's got different communications capabilities, but so far all of these are just empty blocks. My first use case is that I want to reach into some of the data repositories I have where I already have a lot of product data and bring that into my SysML model. And so that means I'm going to launch Syndeia, and I'm going to launch it here from an element in the SysML model. So it's a plugin right now for MagicDraw, and I've launched the Syndeia dashboard. And the first tab here tells me all the different kinds of repositories that I have already set up potential links to, that I have already created access to. That includes a number of Team Center repositories, a Windchill repository at my subcontractor. They've given me some access to their PLM system, but it includes MySQL databases and a lot of other types of connections. We'll talk about some of those later. And in order to have these kind of access, I'm working through the web services that are available to these different types of elements, which means that I need to have access to them. I need to know the URL to reach them. I need to have a username. I need to have a password. I can't get access to any information through Syndeia that the tools would not grant me through any portal, whether it was a client or a web browser or whatever. So the security, the access, is built into the individual tools themselves, not into Syndeia. But assuming that I do have that kind of capacity, let's go to one of those repositories and look at the contents. This is the Connection Manager tab on Syndeia. On the left side, we have that skeleton SysML model I just showed you. But if I go into some of these elements, like the aircraft platform block, there's nothing in there. It's just an empty block right now. I want to start by filling that by going to a Windchill repository and opening up my contents of it. Now, they've happened to given me access to quite a few different things here, but specifically, I'm looking for the aircraft platform. This is what I'm going to buy from this subcontractor. And here's the aircraft platform subsystem. And if I expand it within the tool, I can see that there's 9 different versions, 9 different configurations being managed by the PLM system, by the Windchill system. And if I look at any one of those, I can see that the contents of that, this is a multi-level part structure. The aircraft platform has a body, it has an electrical system, it has an engine, and so forth. So my first task is that I want to be able to take all the information I have in this and drag it into my SysML model. And I'm going to do this by a drag and drop. And it asks me to confirm, yeah, I really meant to do that. I want to create a SysML block structure from the Windchill block structure. And now it's going to ask me for some additional information. Within this PLM system, there are a lot of parameters associated with each of the parts, with each of the items. And I can decide which of those parameters I want to bring over as well. In this case, I'm just going to bring over the phase parameter from Windchill. And I hit OK, and now the process starts. Down here at the bottom, you can see we're going. And this isn't necessarily instantaneous because we're not talking about creating one part in SysML. We're talking about creating dozens of parts because this is a multi-level part structure. And so we're bringing over all of that, and you can see us scrolling down through the bottom. And now, on the SysML side, here are all those additional blocks that have been created. And it's not just the blocks that are created, but the part properties under those blocks that are created. If I expand aircraft platform on the SysML side, you can see that in addition to that phase parameter I brought over, that's now a value property, I've got the part properties of type body, electrical system, and so forth. And if I expand the body block, it has cowling, fuselage, and landing skid parts. So we brought over this multi-level part structure from the PLM system in one task. But we have also created a whole set of connections between each of the elements in that PLM system I brought over and the SysML block I created from it. This is a list of all the different connections. I actually created 25 different connections across that. This top one is between the aircraft platform A8 version in the PLM system and a SysML block called aircraft platform. And so that's important because I can now use those persistent connections to see when things change. Now, if you were paying close attention, you might have noticed that I actually dragged over version A.8 of the aircraft platform. And there was a later version. There is already a new version of this part in that PLM system, A.9. So I can go and I can ask aircraft platform, I have a connection there. Can I see if there is a later version of that part available in the PLM system? I'm going to do a comparison between the SysML system and the PLM system. And it's going to read the two models, and it's going to generate a difference table. And what it's telling me in this table, this is a comparison result, is that our original PLM system that we were linked to was version A.8, but there's now a version A.9. And if I look down in the weeds, the difference is that there's a new part in A.9. It's got a backup electrical system that my SysML model doesn't have, because the previous PLM model it was based on doesn't have. And now I can also go back and I can actually update things. I can go back to that connection. I can say, I want to update the target model information to the SysML model. I could actually do it the other way around, assuming, however, that I am given right privileges back to the subcontractor's PLM system. I could use my SysML model to create a new version in their PLM system of the aircraft platform. But I won't do that right now. What I do want to do is to go back and show you that what was an empty block before in our SysML model is now a populated block. It's got parts. I can start to drag those parts out, and I've already started to populate my SysML model using product data I already had available to me. And now, it's not just a single repository that I can draw on. I've also got to populate the payload. And from the payload, I'm actually going to go to a different repository. I'm going to go to a MySQL database. The assumption here is that I've got a database where I've got a whole set of different thermal cameras or video cameras or radars that I could use as payload components. I've created such a database from, say, vendor information. And this database contains not only the name of the product, but things like its mass and its cost and whatever we choose to store in that database. And in a similar way, I can take each of these individual elements and say I want thermal camera TC3, I can drag that into my SysML model. And when I drag it over, one of the things Syndeia asks is, do you want to drag it over as a specialization of a thermal camera block or an instance of a thermal camera block? And I'm going to say I want to drag it over as a specialization. We'll say yes. I'm also going to use a radar in this particular configuration, R11. Drag that over. Increases specialization. Now if I go back to my SysML model, those parts are now available. So I can drag my radar in. I can drag my thermal camera in. These are the blocks. And I can start to make them parts of my system rather than just a generic sensor. And if you actually zoom in a little bit here, you can see that we've not only brought over the parts themselves, we've brought over the values from that table. They're stored in this case as default values. So the real mass, the real cost of these instruments from the database is now part of the SysML model. When I start to create instances or do mass rollups, I have access to all of this different kind of information. And because, again, this is a persistent connection that I've created, I can do a comparison. If the information in the database changes, I can do a comparison across those connections now. And say, okay, has the price changed? Has the mass changed? In this case, I haven't changed anything yet on either side, but if I had, that discrepancy would show up. And again, assuming you have the right privileges, you could update the information. The final task that we want to do now is that we've created this nice populated model of a system. We've taken SysML as far as we want to take it at this time, and we want to use the model that I've created to generate a bill of materials in our own PLM system. And it's not just the information that I've included here. I've got other information in this model. I have requirements in this model, for example. In this particular case, I brought in a bunch of requirements. I happen to bring them in this case in from a Team Center repository. And so those are now part of our SysML model. And they have connections to elements in my SysML model. So that aircraft platform that I just populated is already set up as satisfying a flight control spec requirement, whatever. We've created relationships in the SysML model between the product data from one set of repositories to requirements data from another set of repositories. And I want to take not only the product data, but all of that other information and put it into a new PLM system. I'm going to go to a different repository. This is a Team Center repository. My subcontractor had wind chill, but this is a Team Center repository. And I'm going to go to an empty product that I've created here in this demo package. I think this one's empty. Okay, this is an empty package right now. And again, I'm going to take a top-level block, the CUAV block. That's the top-level block in my SysML model, which contains all of the parts that I've brought into it and the connections to the requirements that are part of those parts, and just drag them into this Team Center part structure. And confirm. Now, this would actually take about a minute to fully bring this over, because we're talking about, at this stage, literally hundreds of elements. Not just the requirements and the blocks, but the trace links between them. What was a satisfy relationship can become a trace link in the Team Center model. And all of that information is now not only in the Team Center repository, but it remains linked back to that SysML model. So we can now go through that process. Going forward, as we go through the engineering process, we have the Team Center model connected to the SysML model, the MagicDraw model, and we can use them each for the appropriate purposes as we go forward using that. But rather than sit around and wait for the next 30 seconds or so for that to happen, what I want to be able to do is to go back to the slides. We're getting a little bit late in the time now, so rather than demonstrate some of the other capabilities and wait for the software to do them, I'm just going to use a few screenshots to describe some of the things. But I do want to point out that we've actually already looked at 3 different use cases involving SysML and PLM. First use case is that we built a system architecture model in SysML using existing product data in PLM databases. Second, we initiated a new PLM bill of materials from the SysML model once we got it to a certain level. That's what was going on when we left. And use case 3, as we could see, starting from the beginning and going all the way through it, because we have these persistent connections, we can compare the SysML and PLM models, all the PLM models, as we go forward. And when things get out of sync, we can recognize that and we can figure out how to resolve that. Whether that's an automated update or an engineering change notice, that's a work process issue. But the fact is that we can see those problems and we can respond to them in a timely fashion. Let me talk a little bit about CAD. CAD is another area where there are lots of different potential use cases. One of the simplest but most interesting use cases is that if I've created a linkage in a SysML model, and this is one of these simple reference links, to a particular element in a CAD model, either a standalone CAD file or a CAD file being managed by a PLM system, I can actually open that CAD file from the Syndeia dashboard or even from the SysML model itself. I can go to MagicDraw, I can find the block, and I can right-click and say Open Connected Artifacts. And if I have access to a CAD file client or a viewer, I can open it up and show, okay, here's the payload containment volume that was part of this element in my SysML model. In a sense, that's kind of trivial. It just says I can look at it, but it's actually useful to a lot of people. But it gets more complex from there. It may be that I have a part structure captured in a CAD model, an assembly model, basically, within the CAD tool. I can take that CAD assembly model and use it to generate a SysML block structure that reflects that assembly model. So here's the toy car structure in SysML, again with this idea that the elements in the CAD model and the corresponding elements in the SysML model remain connected. And if the structure changes or if the values change, I can see that going forward. I can compare and I can update. Let's talk about something that's even kind of more interesting to some folks. What if I want to create a geometry? What if I want to create a geometric requirement in SysML and use it to launch a CAD design process? In other words, I'm going to capture my payload containment volume in my UAV as a cylinder, which is the payload volume, the bounding box for the payloads, with geometry. And a second feature is a center of gravity. This is the locus of the center of gravity that I have to maintain. These are two geometric requirements that I'm going to pass to the CAD designer, not through PowerPoints or pictures or Word documents, but as a CAD file directly. I'm going to create that bounding box or reference plane or keep out zone in the CAD tool itself. And then the CAD designer is going to go, and the CAD designer is going to do what the CAD designer needs to do. In this case, figure out how we're going to mount some different payload elements within that bounding box. And finally, I can take that CAD model and drag it back into the SysML model, including the geometry of these different elements, the radar, the thermal camera, the video camera. So I now have this information, this geometric information, mass information, center of gravity information, whatever's being calculated by the CAD tool, and it's now part of the SysML model, and I can use it for mass roll-ups, I can use it for requirements verification within the SysML model itself. And when it changes, when the CAD design changes, I can update that information in the SysML model just by calling from Syndeia and updating. So again, multiple different use cases. Moving right along, SysML to Simulink is this is a lot of different possibilities. Again, a lot of different use cases. One use case to actually be able to execute a Simulink model as part of a parametric execution is actually a capability that we've had for some time, but in a different tool, the tool we call Paramagic in this case. What we're doing here is a very different use case. We're going to take a structure in SysML, an IBD, an internal block diagram that is, or an activity diagram like one of these, and we're going to use it to build an equivalent block structure in the Simulink model. Now, it may be that these are empty blocks, and it's up to the Simulink specialist at this point to generate the MATLAB code that goes into each of those blocks. But again, the structure of the two models is maintained through the linkages between these elements. And we could do the same thing from the other point of view. We could take a Simulink model, and we could use it to generate a SysML model, either a block structure like this or an activity diagram. We could generate the activity model in SysML from the Simulink model. So if you've got your system modeling being done in Simulink now, we could bring it back into the SysML model. And because these structures remain linked, we can continue to do comparison. If you hear a siren, it looks like we periodically have the fire engines going by our offices, so I apologize for that. In this case, it's the structure of the model itself, the block structure, that's being compared. It's not the contents of these different parts. I mean, the Simulink specialist does not want the system engineer typically to go messing around with the MATLAB code that he or she has put into these blocks. But you can break things down. Each one of these elements here may actually have its own internal structure. This part C here and this part C block there could have internal structure that looks something like this in SysML or in Simulink. And if I create a library of SysML blocks that contain basic Simulink primitive functions like add, subtract, or scope, I can generate those same primitive Simulink functions as blocks in that Simulink model I just created and actually execute it right out of the block. Interestingly enough, this is a use case that doesn't have too much traction yet, because typically people say, if I wanted to create a Simulink model, I'd rather do it in Simulink than do it in SysML and then translate it into a Simulink model. But these kind of capabilities too exist and represent new potential use cases. Now I'm going to kind of jump ahead to Syndeia 3.0, the one that's coming out very shortly, and talk about some of the use cases there. First thing is, you've got to be able to see the elements in DOORS NG from the Syndeia dashboard, from SysML. Things like repositories, projects, and requirements. And one of the things is, I simply want to create a linkage. I can take an element like a block in SysML and I can link it to a particular requirement in DOORS. And I can open that DOORS interface from that element in the SysML model, the same way we've been talking about before. But there are other cases where rather than link, I actually want to transform. I want to copy. I want to take an element, a requirement in DOORS NG, and drag it into SysML and create a SysML requirement, or vice versa. And that's a second use case. In that case, you have requirements in each tool, but they are again linked. So I can use that to compare across those two tools. If something changes in the DOORS database, I can see it from the SysML tool in the model there. So again, each requirement in SysML is linked to an equivalent requirement, in this case, the DOORS repository, the target. And we can compare and we can sync requirements. And then beyond that, there's additional capabilities. And again, this is an interesting area. One of the questions is, what happens if you want to bring over a complete requirements specification, not just a single requirement or individual requirements or a flat list of requirements, but if you're dealing with things like folders, modules, or collections within the DOORS tool. Can I bring things over there? Can I bring over structures? Can I take, for example, a block structure or an activity structure in SysML and use it to create a requirements structure in DOORS with the same structure? And then these DOORS requirements then begin to be filled in, and they are already linked to the equivalent activities or blocks in the SysML structure. If I'm doing a decomposition of the structure of a system, I can mirror that in a decomposition of the requirements in the DOORS model of that system. So these are some of the capabilities that people are looking for from this kind of a connection. Once again, there's a lot of different use cases, and every time you talk about connecting or integrating these different tools. And lastly, I just want to mention something that's really kind of exciting for us right now, which is what it means to work with JIRA. JIRA is an issue tracking system widely used in the software engineering space. But in a sense, it's really a rather powerful project management tool. Again, there's lots of things I can do. If I've got a link, I can simply use that to go directly to the issues or groups of issues that are connected to a particular element of the SysML model. In other words, I can right-click on my SysML block in MagicDraw and I can open JIRA to the issues that have been set up about that particular SysML block. There are other capabilities. I can take a JIRA issue, we're looking at JIRA here on the right side, and drag it into my SysML model and create a block that mirrors that. That not only mirrors that, but includes a lot of the parameters directly from the JIRA database, things like status and priority. And again, do compare and update. Beyond that, I can take a block structure, a multi-level block structure in SysML, and use it to create an issue structure in JIRA. I can set up my issue tracking system to mirror my SysML activity or block structure or requirements structure model in SysML, so that I can already go directly to the correct issue, which will then get populated with things like status, time to completion, personnel assigned, all the kinds of things you need to build a work breakdown structure for your SysML project. But you're using JIRA to do that. So again, lots of different use cases. Final slide, a final relevant slide, I guess, is to talk about where we are today and where we think Syndeia, not just Syndeia, but really the whole field of model-based engineering is going. Today, in Syndeia 3.0, Syndeia is still configured as a plugin for either MagicDraw or Rhapsody. It is a SysML-centric tool. It stores the connections between tools in the SysML model itself, and it's designed to operate primarily from the system engineer's seat as part of the SysML modeling tool. But that's not where the world is going. System engineers like to think they're the center of the universe, and they probably are, but everybody else thinks that too, that they're the center of the universe. And what we really need is a platform that doesn't make any one tool the center, an enterprise application that's really a set of web surfaces with its own back-end graph database. Because that gives us things like advanced query and visualization capabilities. It means that we can deploy Syndeia in any one of several different modes, as a web browser tool, as a plugin, as a mobile app, which makes it accessible from anywhere in the tool chain. We really want somebody working in any one of these domains, say a requirements manager, to be able to say, hey, I've got a requirement down here in the lower left-hand corner, and I want to know what CAD files I'm going to affect if I change something there. So I want to be able to query across this entire network to ask those kind of questions. And good graph database capabilities give you that kind of power to travel not just across the connections inside of each tool, but the connections between the tools, what we call the intra-model and inter-model edges. Independent, transparently, across the entire engineering model. That kind of individual query is important, and we also need to be able to have more widespread visualization. We need to be able to say, okay, here are my SysML elements, here are my MySQL elements, here are my Windchill elements, Team Center elements, Simulink elements, whatever tools we've got participating in this. How are they connected to each other? What is connected to what? My platform block over here on the SysML model, we can highlight, we can filter, we can say, well, it corresponds to a Windchill platform block and a Simulink platform block. Those are connections that already exist. So these kinds of capabilities are pretty critical. There's some other features that are going to be coming along as well. One of them that's fairly important is to be able to provide an API for Syndeia so that people can write their own custom applications to make use of the capabilities that Syndeia offers. So I've used up my time now. There is a few minor summary slides at the end, but Syndeia is a real tool. Contact us. We can give you a download, an eval copy. There are also some videos that are on our website that go into some of this material. Or simply contact us. I believe that the way MagicDraw sets up these is that we'll have a little time for question right now. I can certainly stick around for a while. But you're also welcome to email us questions, and we'd be happy to do our best to answer them.